this assessment asks us to predict the product of the multi-step synthesis shown on screen. So let's get started. The reaction begins with a primary alcohol and reacting it with chromic acid. Chromic acid and primary alcohols are going to give us a carboxylic acid. So we can go ahead and draw the carboxylic acid here. Now, because we're doing multiple steps, we're not going to show the mechanism of any of these. The next step, we're going to react the carboxylic acid with the thionyl chloride. And that's going to give us the acid chloride. And if we think about why that might have been, or why we're probably doing that, is because we're trying to go uphill, get to a more reactive carboxylic acid derivative so that we can make whatever might be a more stable carboxylic acid derivative in the next step. At this point, we're going to react the acid chloride with the isopropylamine. Note that we have two equivalents here. One of them is going to simply serve as the base. The result of this reaction is going to be this amide. Where the second equivalent is going to grab the proton that forms in the process of making this. This brings us to only the last step, which is to react with lithium aluminum hydride. And there will be, of course, an acid quench in this step at the end. It's not shown on screen, but we would certainly work this reaction up with acid. The result is that the amide will be reduced to an amine. And so we're going to end up with two hydrogens on this carbon. Let's draw that product to see what type of amine we make. Add two hydrogens there. And so we end up with this amide here gives us the secondary amine when the carbonyl is reduced. Again, note that we're replacing in the reduction of amides, we replace both carbon-oxygen bonds with hydrogens.